you guys
basic
have any
as,
questions?
are we even getting this order data?
Sorry. Hello. Okay. Does anyone have any question on whatever we have learned so far? Beans lifecycle, at component, at service, at bean, all those things. Okay. All right. I guess you guys already know about the scope. Is there anyone who hasn't understood the concept of singleton versus prototype and would want me to repeat?
No, sir.
Okay, fine, cool. So we can go with these things today, okay? And once this is finished, right? You guys, like, if you guys go through the tutorial and the GitHub link, I'm not sure if they have updated the GitHub link. Let me quickly check once. They have, I think, yeah, they have. So you guys can check here what the code is. There is an assignment after the end of this course, because this assignment will test you basically on whatever you have learned specifically about Spring Boot. Like, it'll test your knowledge on dependency injection and programming to interface, then these annotations and everything. Okay, it's just the task is very simple, but it would require you to understand all of these things. So go ahead and do that. Like, after this session is over, you'll get to see the assignment. So today, this is what we are going to learn. Okay, I'll work with the same application that I have done yesterday, and you will just know it by the commit message. Okay, for example, um, March Spring. Okay, so let me just tell you the folder structure here. Okay, this must know Java concepts is where all your Java related stuff is. Okay, Spring Core is where your Spring Core related stuff is. If you go inside the Spring Core, you will see there is core fundamentals. This core fundamentals is where your uh, how do I say it? This is where your dependency injection and all those things are explained. Okay, and then here, I think I've been following this Spring Beans lifecycle. This is where your Hello World app is. What I'm going to do today is I will create one more app. It is just for, I mean, sorry, I will create one more folder, and this will be mostly for the app, the application context and whatever we are going to learn today. Okay, cool. So let me just go ahead and let me close this project. Let's close this project. Okay. Let me go to Spring Initializer. Okay. Maven project 2.6.6 Java. Uh, we are under in.geekster.spring. Uh, we'll name this simple Spring, or I'll just call it something like this, simple SB app. Okay, or yeah. What do I call this thing? Let's call it demo app. Demo. Okay, let's just call it demo in Geekster and demo. Name would be demo. Demo project for Spring Boot, Geekster. This is how it's going to be. Jar version is 8. Okay. In the dependencies, the first thing I'll type is Lombok. I'll add this. The second thing I'll do is Spring Web. Okay, nothing else. Go ahead and I'll generate this. This is going to download the zip file. So what I'll do is I will bring that zip file here. I'll say, okay, let me just create this directory. This is going to be about Spring Boot application configuration. Okay. Okay. And that's it. Yeah, I guess this is fine. Open. You can see we have the Spring application demo. Okay. So first thing is we'll go to our starting class here, which is basically it's still resolving dependencies. So give it a minute. Okay, looks like this is taking some time. So while this resolves, I'm just going to start showing you a few things from this. I think added a few more things.
Sir.
Yeah, recording.
Today, your screen not completely visible.
Not completely visible.
Suggestion box.
Acha. Okay.
Means
Okay.
a suggestion box.
Okay. Okay. Let me share again. How about now? Like, let me type something here.
Suggestion box एक बार पता लगे तो.
Ab?
No sir.
Still not visible?
Half जैसे बात. No sir.
Acha, let
just
me.
like the last time.
Let me join again. I don't know what's happening. Let's check now. How about now? Hello? Is it completely visible now?
Okay sir, yes sir.
Okay.
Visible.
Okay, fine. Cool. Okay. I don't know, man. Zoom has some issues. Okay. So what is our task today? We are going to create something called greeting service. Okay, what this will do is this is going to print a greeting message on startup. Okay, then it will basically print how do I say it? It's gonna print a greeting message on startup, and then it will basically print any random message from uh, a list, okay, on startup, okay, and then have the random messages injected from outside. We'll understand what this means, okay, but let's just try solving this. Okay, business logic says that I have to print a greeting message on startup. Okay, first thing, create an interface. All right, so I'll go here, I'll say package services, okay, and I'll call it interface greeting service. Okay, this guy is this guy is not going to print it, it's just going to generate the greeting message. Okay, so don't ask again. It will just have a single method. It is going to return a string, generate greeting message. Done. Okay, single method. So in my services, this is my interface. I'll go ahead and create another package called Impulse. It stands for implementation. And I'll create this class default greeting service. Okay. Yeah. It will basically implement greeting service. Okay. Go ahead and implement this greeting message. So what I'll do here is I'll say private string private static final string greeting message. Okay. Hello. Okay, this is our message. Okay, and what this will do is it's a very simple thing. It'll just return this greeting message. That's it. And can anyone tell me what the annotation here would be?
Service.
Correct. Okay. Yep. And what I want to do is I want to check the logs if the call is happening here or not. So I'll use this SLF4J. Okay. What I'll say here is info. Okay, I'll say before. No, I'll just say returning greeting message. Okay. Done. So if this log gets executed, I know this call has been made. Okay. Done. Now I can do this startup thing on demo application here itself as post construct, but I would not touch this. I would actually create one more class here, not inside services, but outside. I'll call this thing components. Okay. And I'll say, I'll call this thing startup aware component. Okay. Don't get confused by the name. Basically what it says that it's a component which is going to be aware of when the machine starts up. Okay. Or let's just call it this thing, life cycle aware You can see here one thing that I have decided to call it number one component. Number two, I'm not going with interface because it's not something that the business logic sits in. It's just a single time component. Okay. So lifecycle aware component. That's it. This one here, I'll just annotate with add component here. Okay. This guy is going to fetch the greeting message from the greeting service. So it'll say private greeting service. Acha. Can anyone tell me why I am always using private here?
Because outside classes must not access it.
Yes, these are private variables to this. Okay, because if the outside class gets access to this particular thing, they might be able to understand the logic and everything. Okay, we don't want that, so we make everything private here. Okay, so what I'm going to do here is I'll just say public void on startup. Okay, I'll need the logger. Can anyone tell me why we're using logger and not system.out.println?
We can do the same with system.println, but to give meaningful message.
Yeah, it'll most importantly, it'll tell you the class name it's coming from. If two classes have the same message, you won't get confused with logger, but you will get confused with system.out.println because it won't print the class. Okay, greeting users on startup. Okay, I'll say greeting service dot generate greeting message. Very simple thing. There's nothing fancy on this. Post construct. This should be done. I'll go here. Demo. The first thing will take some time because it's going to do this. Skip the tests. E for error. And right now there is no Java class. Okay. Let me show you something else. It's a quick fix. Right. So we have been using this and this command, right? Basically, in the first part, we are cleaning and building the Maven file. And then the second one, we are using basically this thing. This entire command, if I copy it, this entire command is actually equal to something called mvn spring boot run. Hang on, let me just confirm it. Mvn spring boot run, correct. Yes, cool. So what this basically does, this long command, it is done by this command only. The only issue with this command is that if you are making very frequent changes, this command, what it does is it uses some sort of caching. Like it has it uses Maven's own memory to cache some of the files, which means that if you are making changes to those files, you will not see those changes will not be picked up by this thing. Okay, many a times what happens is this particular command is going to ignore this field and it will only run this. Okay, but in other cases, like if you're not doing any frequent changes or something, you can just go ahead and initialize this command. Okay, so I'll copy this and I'll get rid of this. We have a problem. Okay, the problem here is it says that error creating bean lifecycle aware component invocation failed of invocation of init method failed, exception java bean null pointer exception. I think I know what. Let me just show you, like take you through how to understand if when you see an error like this, how you would do this thing. So for those of you who are working on Java exception for the first time, anytime an exception happens, especially in any Java program, right, they would give you this thing. This entire thing is called a stack trace. Okay, right from the beginning, it gives you the parent exception. Then it could be possible that maybe some class threw exception A, but then whoever was calling that method it is going to wrap that exception and send something else. You can see here that the original exception here was null pointer exception. Okay. But this guy, because it is handled by Spring application, this Spring application basically wrapped this thing inside something called bean creation exception. Okay. So you have to, when you are looking at there, when you're working with Spring applications, there may be a possibility that there are, the actual exception is 2-3 layers inside. Okay. So just go through this thing, or you can just go by this thing. There's, you will always find this thing called caused by. Caused by basically says what the original exception is. Okay. And the very next line will tell you where the first thing happened, like what was the origin of this exception. You can see the origin of the exception was on startup method at lifecycle aware component Java 17 line. So if we go to this class, okay, it says this is a null pointer exception. Why? Because
Auto wire.
we did not give the auto wire. Okay, that's all. So this is how you basically trace an exception. This is the stack trace. Always look for this caused by, and then it will have the message, and then immediately next to that, it will tell you where the first occurrence is. Okay, cool. We'll, as we start working, we'll see more of these things. So now let's run this. Okay. That is strange. We're using log info on this. We're using, what are we running? Okay, where are the logs? Profile default initializing root geekster. Okay, look at this. Yeah, my bad. I was looking for logs here. Okay, anyways, look at this. So the first message coming is from default greeting service, which basically says returning greeting message, hello there, students of Geekster. Okay. Then in the lifecycle aware component, I'm getting this greeting message, greeting users on startup, hello there, students of this thing. Okay. So this works fine. I also want you to pay attention to this particular line here. Okay. What this line basically says is that, remember I told you that when somebody asked me the difference between jar and var, I told you that var is something which is just the Java classes, and the jar basically has the web server on which this runs. So maybe I think this is would be a nice time to explain this thing a bit detailed. So this is like basic computer science. Our machine, right? Any machine, any computer you take, they have ports. Okay, every computer has ports, and like basically in the olden days, right? Maybe if I could show you something. First generation computer ports. So this is the first generation of computer. Okay, and you can see that it had several of these things. So if you wanted to program something, you would plug out a wire and plug it in this port. If you wanted to run something else, you would plug out this wire and plug it in this port. Okay, there were many such ports like this. As computer became more smart and more concise, these ports, this actual hardware ports, became virtual ports. Okay, so your machine actually has many of these ports. Every application that you run on your computer, they always have to occupy a port. Okay, for example, this thing, this particular thing, okay, forget about this part. This is the default port 8080. Similarly, you have ports ranging from, I think, like there are many ports which are already used by the OS, and then there are ports which are open for use, and these are the ports that these such applications use. Like if you're using a Micromax, sorry, if you're using a media player, or if you're using a Word document, right? Pretty sure that be sure that it's probably using some port underneath. Okay, give me a second. Okay. So that's basically the concept of port. So where does this come in? Say this is your Java classes. Okay, this is your Java classes. Now, this guy, if you execute a Java program, it'll execute once and then it'll shut down once the execution is over. Okay, one second. Huh. Once the execution is over, it'll be dead, like the program will finish. In order to keep it alive, you would need something called a basically a container. Okay, this is what a container would be. This container would be, it could run on 5005 or it could run on port number 3003. That means if somebody wants to talk to your application, they would have to basically knock on the door number 303, sorry, 3003. In our case, when it says that application is running on port 8080, that means anybody who wants to talk to this particular application, okay, they would have to knock on the door number 8080. Is this clear to everyone? This is basically what web server does. Okay, Tomcat is a web server which will wrap this thing around. Okay, your Java classes and everything will be sitting here, and this will be running on, let's say, port number 8080. Anyone that needs to talk to your application will be calling in this 8080. Okay, so now 8080 is a very popular port. Like if you run Skype runs on 8080, and you will not be able to use that port simultaneously by some other application. Like if you're running a Spring application and your Skype is running there, it'll clash. Like if Skype is running, this will give you an error saying the port is already in use. Okay, now why am I mentioning this thing? I'll come to this. So if you see here, there is nothing in this which basically says anywhere which port to run your application on. Nowhere in any of these files it is mentioned where ideally you should run a port. So where is this port coming from? Java cannot decide on its own that it has to run on port 8080, right? So essentially, if you look at your POM file, I told you that there is a parent project. This parent project is what is supplying the values that you do not give. Okay, so the difference between a Spring application and a Spring Boot application is a Spring application would probably not have a parent like this. Okay, a Spring application is just a bare bone skeleton. Spring Boot application is, you can think of it as skeleton with a little bit of flesh here and there, and you have to basically put your things here and there, and it should be done. Spring Boot is already 60 to 70% done for you. Okay, so whichever components you see working just like that, always be sure that those components are configured in the parent project. Okay, now this in Spring Boot also gives you the ability to change these properties. Okay, these things like the port number and all of these things, right? These are called properties of the application. Okay, so just like how dependency injection is maintained here, you can also inject a value into your actual Spring Boot application from outside. For that, we have something called application.properties. Okay, this is what we have. Most new projects will not be using application.properties. They will be using something called application.yml. Okay, because YAML is the new way of writing this thing. Okay, let me tell you why that is the
Sir,
case. Yeah.
excuse me, sir. I have a
Yes.
question here.
Yes.
Sir, what is the difference between YML and XML files?
YML and XML files. XML
Yeah.
files are extremely verbose. Like if I could give you an example here, let me show you how it is. Okay, let's say you are writing details about a student. Okay, so in an XML file, you would have a student tag. Okay, you would
Yeah.
also need to close that student tag. Okay,
Yeah.
then you would have something called name tag. Okay, which means you would also have to close this tag. All right, sorry, wait. Okay. Then you would give your name, let's say John. All right. And similarly, you would have, let's say, email tag, and then you have some at gmail.com. Okay. This is your XML. You know how it's going to look in YAML?
Yes. No, sir. Regarding YML, I have no information.
This is how YAML looks. It looks much more concise, and it is basically the preferred way of doing it, because a typical, like some information about a particular person, like let's say student having name this, roll number this, studying in this university and everything, for XML it becomes very, very difficult. XML becomes particularly difficult when you have deeply nested objects. For example, if you have something like this. Okay.
Yeah.
Then inside of this, you would have to have something for a city. Okay. Then inside of that, you would have something called pin code, and all, it becomes extremely difficult. This is much more concise because it will be like this. This is much cleaner. Okay. This is much cleaner and is easier to read. That's why everyone prefers XML. I'm sorry, YML. Okay. Even like all the modern APIs that you work with, like if you work with any company like Flipkart or Amazon, okay, they like majority of the services are going to use not XML but something called JSON, which we will see in the next couple of
Yes.
tutorials. This basically
Yes.
YAML is like the whole concept of YAML actually came from looking at JSON, because JSON is extremely easy to write. Okay.
Yes. Yes. Sir. This thing, like somewhere will use it in a Postman.
Yes. Correct.
Okay.
So you can use XML, but like there's no point of using XML. It's like a dead thing. Only in our like very legacy projects you'll see XML like this. Okay, cool. So this is how a YAML looks. Now I'll tell you the reason why I'm choosing YAML instead of properties. So let me just go ahead and create this file here. Call it application.properties. Okay. Okay, yeah, leave it like this. So let's say I want to how do I say this thing? Let's say I want to say that okay, let's say I have this information, MySQL database. How can I make the same mistake again? MySQL database. Okay. Port is, let's say, 300333, and then username would be something, password would be something. Okay, this information, how I would write in XML, how I would write in .properties file, and how I would write in YAML. Okay, so this is the properties file. You would write this MySQL dot port MySQL dot port this thing. Then for this you will say MySQL dot username, MySQL dot password. Okay, this MySQL is really unnecessary, and when you have deeply nested objects, like let's say config, okay, then inside of this you have conf a, and then inside of this you have some other thing, right? It becomes extremely difficult because then you have to write MySQL dot config dot conf a dot this is this. Okay, the next time you type another property of this thing, let's say instead of this thing like prop a, actually this is one property, and then you have to type another prop b. You have to basically type this thing. You have to keep typing this thing. This part is really unnecessary. It's not required at all, but you have to keep typing it because all of these properties have changed. So what YAML does is YAML says don't do it like this. Type MySQL. In there, you have these annotation, I'm sorry, you have this indentation. Okay, this thing is called indentation. Okay, then here you say port, give your port number, then you say username. Okay, give your username HHH, then give password. Okay, then if you have config, do a config. In there you would write conf a, in there you can write prop a, then some value prop b, some value. Okay, this is easier to understand, right? You could just take a look at this thing and you can tell that this guy is a child of this guy. YAML and application.properties does. Okay, any questions about this? No questions? Okay, so let's just understand what application properties does. Application properties is basically a typical file, and it is there in every like any project that you work with, whether it's the Java based Spring Boot project or JavaScript based Node.js project or Python's Django or anything. You will always have a file from which you basically inject your values into the application. Okay, so if you specify something here, when the application starts to run, it will basically pick these values from here. So application.properties or application.yaml is basically a file where you can specify the application level properties and your own custom properties. Okay, we'll see both the things. Okay, so the first thing that I want to do here is I don't want my application to run on port 8080. Instead, I want this to run on port 3030. So for that, what I have to do is I have to say port. You can see it already gives me this thing. Okay, if you're using IntelliJ, it'll be extremely easy for you to work. But if you don't, let me just explain what's happening here. Server. Ideally, in a properties file, you'll write server.port, then 3030. This is how you would write in a typical properties file. This same thing you will be writing like this: server colon port colon 3030. Okay, that's it. So now if you run this application, you can see that instead of 8080, it will run on 3030 if it is not occupied. You can see this thing that it's running on 3030. So this is uh, a property which is going to be used by application itself. This is a property. These keywords, right? These keywords are predefined. Okay, these keywords are predefined, so you cannot use a server port for your own use. Okay, if you specify a value on server port, it is going to be consumed by your application. If you were to use something else, like if you want to call some port, right, which is your custom port, you cannot use this thing. You can always have something like my port or something like my properties and then port, and then you can, right, then Spring would not understand this. Like Spring will not inject any values mentioned here into itself. But whenever you use some recognized keyword, it will inject the value into itself. Okay. So this part here, sorry, this part here is actually your custom property. Okay. This part here is your application property, because these values are going to be consumed by the application. Okay, for example, I want my application to have a name. Okay, so the key for that is Spring this application, okay, name. I would probably pass a string here. Okay, this would be the name of my application. Okay, this again, this entire thing, if you were to write this in properties file, you would write it like this: spring dot application dot name. Okay, something like this. So as your names go longer, it would be like this. It would be vertical, like it will be extending in this way, in this direction. You don't want that. Okay, cool. So that's how it is. Let's just run this again. I'll get rid of this for now. So you can read the different types of application properties that Spring uses. Most used applications are basic, like most used properties are server port, and then sometimes the application name. Then you have some DB configuration, which we'll learn when we get into the database. Okay, these are preserved things. All right, so that's it. Yeah. So let's.
Hello, sir.
Yes.
Sorry to interrupt you, sir.
No,
As you spoke regarding the database, are we going through any JPQL things here?
JPQL thing is a part of the database tutorial. I have at least, I think, 5 sessions for database related. I think the last part of that would be on the JPQL queries. Okay, we won't write any native SQL queries. We'll focus more on JPQL queries. So Spring actually has it's actually 3 ways of
Yes.
retrieving data. You can write native SQL queries, which is not recommended. You can use their method inference, like you write the method in such a way that it generates a query on the go. It's a very interesting thing. Second thing is JPQL queries. Okay, we'll learn all of
Yes.
them when we get into the database module. Okay,
Sure. Thank you, sir.
yeah, cool. So that's there. Now let's get back to our task. Okay, what was our task? Task was that greeting service, print a greeting message on startup. This is complete. It says print any random message from a list on startup. So basically I now have to have a like I can either mutate my service, like I can change this method in my service, in my greeting service, default greeting service. I can either change this mechanism to accommodate these changes, or I can implement one more service. Okay, so I'll show you both the ways. Okay, so right now what I'll do is I'll change this, I'll mutate this service itself, and then I'll basically implement another service for the third task here. Okay, cool. All right, let's go ahead and change this. So what is it saying? It basically says that you have to randomly pick this thing. Okay, so let's say that instead of this greeting message here, I'll comment this private static final list. Okay, a list of strings, greeting message list, new array list. All right, done. What I'm going to do is at the startup of this application, when this application is ready to be used, I will dump in those values. Can you tell me where I should write that? Should I write it in constructor or should I write it in init method? Task is that I'm going to, as soon as this application is ready to be used, it should have all of these values there. Like, let me remove the static here. As soon as your application starts up, it should have this array filled. So where should I write this? Where should it's already initialized. Where should I dump the values? Where should I put values in this list? Can anyone tell? Okay, 2 ways of doing this. You go the plain Java way, where you say default greeting service, and you say greeting message dot add hello hi. You can either do it this way. This is the plain Java way of doing things. Okay, there's nothing Spring Booty about this. Okay, if you want to use Spring Boot, come here, make it public, or just make it like protected something. I think even private will work. Let me check. Private void initialize. Okay, these are the two ways you can work with this. Okay, let's just say for now we will keep aside the random logic and we'll return a fixed part. Okay, so we'll say greeting message.list.get. Let's say we'll get the first one, I mean the 1th position. Okay, and similarly here, or let's just do this. Done. Okay, imagine that this is doing the random thing, which means it'll basically do the same thing again. Actually, there is a logic for running it randomly.
There, simply we can create random number and divide by 3. Reminder.
Correct. Yes. That's the logic. Okay. You can see returning greeting message and this thing. So that's the logic for where is it? Yeah, we can, like how he said, we can use this private final random. We can generate a random number. I think it says till what you want to seed. And then basically here, what you can do is you can say random next int %3. Okay. That should not throw an array out of bound exception. Let's take a look. Yeah, it didn't. Great. So this time it ran hello. Oh, it's returning hello all the time, is it? Okay, we'll take a look at why this random, how to implement this random function. Okay, that's not the point here. We'll just use this. Okay. For now, let's just assume that this is generating a random function and it's doing it. The next task here is to basically have the random message injected from outside. This is the part where it's important and it's going to get interesting out here. Okay. So let's say, before I jump onto this, let me actually have a message injected from outside. When I say outside, I mean outside the application, like it's not in the Spring container. It's going to be coming from outside. Okay. For you to do that, you have to go to your application properties, and here you have to set, let's say, greet. Okay. Or even better, let's just say messages. All right. Then you have your greet here. In this, I can say, hello students, something like this. Okay. Now, this part will be injected into my application. Let's see how we do that thing. Okay. So we'll get rid of, who's this?
Sir.
Yeah.
Sir, why you using percent E3? You are using %3, sir.
That's just the logic, man. Like it's the logic of generating the random number. Don't pay attention to this, man. I'm not teaching how to generate a random number here. I'm just teaching this. Forget about this. Okay, let's forget about this for now. We'll see this later. Let's just say that we're returning this thing on the first place. Okay, don't worry about why we're using random and everything. That's not the point of this discussion. Just focus on what I'm doing here. I created a service, and that service is basically implementing this greeting service, and that service is being used in our lifecycle aware component. Okay, on startup. Okay, now the task here is I have to have a message injected from outside. Okay. So firstly is you need to set your custom property on your application YAML file. Okay. This is your application YAML file, or if you're using application properties, then that in here, this is how I'm basically saying that all the messages that are going to be here, they're going to come from this thing. Okay. So the structure here is messages, and inside of that you have a greet keyword which has the actual message. Okay. How do I read it in my default class here? So what I can do is, this is going to be a string. So I'll say private string greet message. All right. Now, basically what I'm doing here is I will use this variable to inject this value into this variable. Okay. This is what I'm trying to do. Let's see how we do this thing. To read any property, any single property of your application, right? You would use this annotation called value. Okay. If you're using Lombok, you will have a collision with this because Lombok also has something called value. Don't use that. Use the one coming from org.springframework.beans. Okay. Use this one. Okay. Then inside this, you are going to write a placeholder, which is basically double this thing. Okay. Before that, you would have to give the $sign. Okay. The $sign basically says that this is called SPEL, Spring Expression Language. Okay. This type of language is called Spring Expression Language. So basically you put a $sign there, and then you give a placeholder here. In this placeholder, you're going to write the actual property name, not like property key, not the value. Okay. So what is the first in the line? It is messages. So copy that and paste it here. Okay. Then you want to access a sub property of this property, right? To access that sub property, what you do is you would put a dot. Okay. This dot, when it is evaluating this language, it will go in here. The moment it encounters a dot, it knows, okay, I have to now read something from in here. Okay. So it will go here and it will basically read this particular file. So you will have your messages.greet, and that's pretty much it. If you want to see this thing, all you're going to have to do is, instead of this, let's just change this to greet message. Okay. Take a look at what we're getting here. We're getting hello students. All right. So this is how you inject a value from an application to this thing. Okay. So what did we do here? We specified a custom property on an application file. Then we basically defined here, like we initialized, like we defined a variable into which we will inject that value. Then we have annotated this with add value. The moment you say add value, it is basically going to read the property from here. Add value in there, you give this $sign here. This $sign basically says that look for a property. I mean, this $sign and curly braces basically says that at the runtime, this value will be replaced by some other value. That's the placeholder. Okay. In there, what happens is at the runtime, it first looks for any property called messages. It'll go ahead and it'll find the messages there. Then when it encounters this particular dot, it will say that, okay, I'll have to check the sub property of this. Okay. You have a greet here. Okay. If you had something like this, hey, okay, then you would have to basically change this to greet dot hey. Okay. Is this clear with everyone? Or is there any
Yes.
question? This is clear, right? This is how you basically read an application property. This is a very simple example. We will get into a more complex example, but before that, let's take a 5 minutes break. Okay. All right, I hope everyone's back. I won't be needing this window again. Cool. So what we saw here was we actually injected a greeting value from outside, which means I don't need any of these things anymore at this point. I can get rid of all of these things. Okay. Now, so this shows us how to basically inject uh, a particular value into our bean, okay, from outside. Let's make things a bit more complex. Let's now say that you have random messages injected from outside, okay? So now you have a particular requirement where it's not just a simple read, like a simple key value pair that you have to read. It's a list of things that you have to read, okay? First, let's try and understand how a list or an array is written in a YAML file, okay? So I'll keep this the way it is, okay? I'll create a new key called welcome, okay? This is basically going to have all the welcome messages. Now, in order, if I write something like this, it's a simple key value pair, okay? It's not a list. In order to write a list, you would basically give a dash space your message. Welcome to Geekster, okay? Number 2. So you can see, like, the moment you press this thing, it is automatically recognized as a list. So this dash is already given, okay? Welcome to this tutorial, okay? And then let's say another thing. Welcome to this Spring Boot session, okay? This is how you generally write a list or an array in YAML, okay? Now, this is the first part of it. Second part is how do you retrieve this in your actual service class, okay? So you can see that this is not going to work anymore, okay? Let's see if this works. Okay, and let's just say that let's get the very first one. Okay, let's see if this works. So it fails, okay? Why does it fail? Let's go to the top of this thing. It says unsatisfied dependency exception, okay? Where is it coming from? It's coming from the fact that it's trying to create a bean with the name lifecycle aware component. Check this thing very clearly. I told you that if you do not provide name to a component, it will take the, like, where is my this thing? If you do not give the name, it will take the class name, but the first character will always be lowercase. So this is called a camel case character, camel case. Yeah, this is just in camel case, okay? Now here it says there is a nested exception, okay? So what is the nested exception here? It says that illegal argument could not resolve message, could not resolve placeholder. Actually, let me highlight this whole thing, okay? It says could not resolve the placeholder messages welcome in value this thing, because values work for a single value and not a collection of values, okay? Value annotation can work only if you have to pick a single object, okay, or a single value. If you have a list of values, then there is a different way to do this thing, okay? This is where you get introduced to something called configuration property, and let's see how this is done, okay? We'll create a simple package. We'll call it configurations, okay? Or let's just say configuration properties, okay? In here, we'll create a simple Java class, okay? We'll name this message property. Okay. Here I'm going to have a list, and I'll basically call it. One second. Let me just do it this way, much better. Okay. Okay. You guys can see the split, right? It's not like half is visible and half is not visible, correct? Guys,
Yes, sir.
you can see the screen, right? Okay. All right. So what I'm trying to do here is I'm trying to create a class which will model this particular thing. Okay, which will model this entire thing. Okay, so I have named this as message property. What is the first property in there? Greet, and that is of string type. So I'll say private string greet. It is very important that this variable name, when you're defining a property like this, the variable name here matches the key name here. Okay. All right. Next thing is basically a list. Okay. So here what I can say is private list of string. Okay. Welcome. All right. Done. Then you will have something called config. We already saw the annotation configuration, right? Key called greet, another child property key called welcome. Okay, which is why it doesn't matter what you name this class. This has to be very important. So first we have to ensure that this is the property. So we'll say messages. Okay, then when you do this thing, when Spring is actually going to compile everything, it will go and look for this particular messages keyword. If it finds it, then it will go on to check if any of these things match with any of these things. So you have a greet here named as greet. It will go and check if there is a greet here or not. If there is a greet, it will go and map that value. If there is a welcome, it will go and map this value. For now, just to see if it works or not, I'm going to uncomment this and I'll see if just the greet part works. Okay. This is done. Message property is done. What I'm going to do now is, so this is a configuration property which will be modeled after this. If I close this, or let's say I bring it over here. Okay, this is the default property. I will actually get rid of this. Okay. What I'll do now is I will say private message property, and this will just be an auto wired. Okay. Then I'll get rid of this, or I'll just say it in this itself. Message property dot. Okay. I have no method for getting this thing. This is where Lombok comes in. Okay. Let's see how Lombok helps here. In the message property, I have a property, but I have not set any getters and setters. So one thing you can do is you can just, if you're an IntelliJ, you can say alt insert, use this getters and setters. Okay, it will automatically do this for you. But if you don't want to do this, get rid of that. Getter, setter, and now you will be able to use this. Okay, did you see what happened here? Let me show you what happened. This is the magic of Lombok. Okay, if you have, let's say, 10 properties here, if you were writing plain Java code, you would have to write 10 getters, 10 setters. Don't do that. On the class itself, if you are going to have all the properties, if you're going to set getter and setter on all the properties, then you set getter and setter on the class level itself. It will apply to everything. Let's say I had a requirement where I said that the getter will be set only on this and setter can be set on anything. Okay, In that case, I will remove the getter from this point. I will leave, because the requirement is setter will be applicable to all the fields, but getter will be applicable to only this. Okay? That's it. You don't have to write getters and setters and all those things. Okay. This is how Lombok helps. This is why I love using Lombok. Okay. So what I'll do is I'll just say getter. Has any of you ever used Lombok before? The folks who are working with companies,
Yes, sir.
you have used, right? Cool. Okay. So that's it. And what I'm going to do here now is I'll say get greet. Similarly here, I'll just say return greet message. Acha, message property dot get greet. Okay, this should work. So if this works, we'll know how to read a particular application property. Okay, auto required. What is this happening here? Particular implementation is a property that could not be found. Acha, it could not be found because I have forgotten to give the add configuration annotation here. Yeah. Cool, that works. And let's now inject this. So I'll just print this get welcome wala list. Let's see if this works. Okay. Pay attention to this. Returning greeting message, hello students. This is fine because it's coming from this. Okay. Let's go to message property. It's coming from this particular thing. Okay. Then I have set these things, okay, which is a list, and the key value is welcome. Here, what you did is you said you can see that returning welcome message, and this is how it basically shows the list of messages that have been picked up here. So what we did here was we actually injected a list of information from set on our application properties into our bean. Okay, so there are two ways of doing this thing. If it's a one-time read, okay, like it's just a key value pair that you have to read, then you can go ahead and do this. If it's just if it is something more complex like this, you can model a class after this particular property and then have it this way. If let's say I say that I don't want the greeting message to be read here, I can simply get rid of this. Okay, and then it'll work just fine. Okay, if I'm pretty sure some of you are lost here, like what I'm doing, so I'll repeat again, don't worry. Yeah, you can see welcome to greeting user on startup, welcome to Geekster. Okay, where is this coming from? This is coming from this particular message because I've given the index as 0. Okay, so you can see that even though I have a class modeled after this, I decidedly chose not to pick this thing by removing this particular thing. Okay, that's it. So this is how you can actually use application properties. Remember this part of the property is the application properties. This part of the property file is your custom property. Okay, and you can do things a lot more complex than this. For example, say I want to have a map. Okay, so I'm saying custom custom messages. Okay, you will say MSG1 hi. Okay, MSG2 hey. Okay, let's just take this for example, and then you have something like I don't know, MSG, let's say K1 would be V1. Okay, and K2 V2. So that's a pretty complex this thing, like it has a hierarchy of this. In order for you to read this thing, you could go ahead and create a, you could create another class called custom messages property. Okay, and then basically write this, like you can have, you can, so there are two ways of doing this thing. um Let me close this, let me close this, let me close this, let me close this, let me close this. Okay, okay, there are two ways of reading this thing. First thing is I say configuration and I say add configuration properties, and I say that I want to have the custom messages. Okay, custom messages. All right, then what you can do is you can say private private string msg1 private string msg2. Okay, and then you can have something like private map of string msg. Okay, that's it. You can have this thing. I'll go ahead and I'll say getter, setter, and there's a method called toString. Okay, toString is going to basically print everything there, and I can check this thing in our lifecycle aware component. I can say that. So one thing to notice here is in my previous case, I was just using add value, right? Here, what is happening is the moment you use something called configuration and configuration properties, it becomes a spring bean, which means then you have to use this add auto-wired component. And what I'm doing now is I'm using the field injection and not construction injection or setter injection. Okay, so I'll say custom message property, okay, add auto-wired, and on startup I will simply just display this. I'll simply say log.info custom okay, custom message is not valid, invalid characters M. I think I have messed up something. Custom acha, this has some issues with this custom. How about this? MSG1, MSG2, MSGS, custom hyphen messages. Okay, should work now. What? Configuration property custom messages is not valid. Invalid characters, this bean lifecycle. Canonical names should be kebab case. Acha. Wow, they have a name for this, man. Kebab case. Nice. Okay, so let's make it kebab case. This is my kebab case. Basically, it's saying that you cannot use either a camel case or something like this. Use a kebab. I mean, kebab case. Cool. Why is it kebab? Because that's a chic and that's just, yeah, never mind. Yeah, okay, go ahead. Cool, you can see custom messages, custom message property, MSG1, hi, MSG2, hey, and then you have a key value pair, okay? This is one way of doing it. This is one way of reading the messages. Another way of reading the messages would be to basically, no, I think that's it. Like if you want to have something like this, now this should be fine. This is a good way of reading the message. The other one would be complex. Don't worry about this. So this is how you can read complex complex structure of application properties into your file. Okay. So does anyone here want me to repeat again what I just did?
Sir, do we have any real-time application of this?
Oh my God, yes, we have lots of real-time applications. When we start working with Spring Boot applications, you'll see that many of the so basically the credentials, right? Application credentials, secret
Okay.
passwords and shit like that. You cannot, you should not hard code them. So you would have to inject it from outside. There are
Okay.
many applications of this thing. Will as we start going into this, the real Spring Boot development using database and everything, you'll see structures like this. Especially when you go into like, especially when you work with Kafka or something like that, right? Or
Yes.
Redis cache or something, you will see things like this being used very, very frequently. Okay, but I cannot demonstrate that because Kafka is out of the scope here. But this has a
Yes.
very real use in the industry.
Sure,
Okay.
sir. Sure. Thank you. Thank you, sir.
Yeah. Okay. Anybody wants me to reiterate this thing or re-explain what happened here? What I'll do is I'll make things a bit simple for everyone here, so that if you are reading this, if you're going through the code or the video, it should not be difficult for you. So in my default greeting service, what I'll do is I have this line commented. Okay. If you're watching the video and then also going through this, you will know what this means. Okay, great message. Yeah, Abhishek.
सर आई हैव अ डाउट ये
Yes. हाँ.
डिफॉल्ट ग्रिड सर्विस डॉट जावा पेज में सर ये लाइन नंबर 28 डॉट
28.
गेट ये 0 ये इंडेक्स नंबर
हाँ, ये इंडेक्स नंबर है, ये इंडेक्स नंबर है। देखिए यहाँ पे क्या हो रहा है, बेसिकली यहाँ पे हम लोग एक लिस्ट से उठा रहे हैं, ठीक है, सारे चीज। तो यहाँ पे गेट वेलकम है। गेट वेलकम बेसिकली क्या है, इस प्रॉपर्टीज की है। तो अगर हम लोग यहाँ पे जाते हैं प्रॉपर्टीज में, हम लोग यहाँ पे देखेंगे कि ये एक्चुअली बेसिकली लिस्ट है। तो अगर आप तुम्हारे यहाँ पे एपीआई कॉन्ट्रैक्ट है कि तुमको एक स्ट्रिंग रिटर्न करना है, तो तुम लिस्ट रिटर्न नहीं कर सकते, तुमको एक कोई भी इंडेक्स उठा के देना पड़ेगा। तो मैं यहाँ पे एक 0 इंडेक्स यूज कर रहा हूँ, समझे?
Fine, sir.
Cool. Let's see what's left. Task wise, reading externalized configuration property file using add configuration properties. So that's about it. Okay. This would complete the basics of Spring Boot. Like if you are thorough with all of these things, you at least know how to create, how to register a Spring Bean, how to inject a Spring Bean, how to read different properties from the application file, how to how to capture the life cycle of a particular bean. I showed you 2 ways. One is using annotation, one is using implementing that initializing bean aware. I would suggest that you go with the annotation wala part. Okay. One more thing is all of these beans, right? These beans are by default singleton. Okay, as in you don't like, it will be created only once and reused everywhere. If you wanted any bean to be like prototype, I'm pretty sure you know what prototypes are. You would basically go ahead and have this thing called scope, and there you would specify as proto. I guess you have already had this thing. Okay, by default it is this. Okay, that's it. Okay, now a very valid question is, when should I use a bean of singleton type? When should I use a bean of prototype? Okay, so has the instructor told you about this, like why and when you should use something like this? Anyone?
Sir, I didn't attend that lecture. I don't know whether it is been said or not.
Okay, so you know the singleton prototype part, right, Vishwesh?
Yes, sir. I was just about, like, I just heard that class for half an hour when it was being told for singleton and prototype thing.
Correct.
But not, I cannot say that I'm thorough with that.
Okay, so let me just briefly tell you about this. So in Spring Bean, right, there is a in Spring there are different types of scope. You can actually do this thing, Spring Bean scope types. Okay, there are singleton, prototype, request, session, application, WebSocket. Okay, majority of the applications are going to use singleton. Some of them are going to use prototype. Some of them are going to use a request. Okay, so what exactly are these things? Singleton, as have already been explained to you, is something that that is created once, and then every time somebody says that I have a dependency on this, the same object is injected into the memory. Prototype is uh, every time something is required to be created and destroyed, you would be using prototype. Okay, uh, request is a very interesting thing, because every time you have a HTTP request coming in, if you're confused about what exactly HTTP request is, don't worry about that. Just know that every time somebody wants to talk to your application, at the time anything that is scoped as request will be created. Now, when do we use these things? Okay, one of the very practical use of this particular scope is capturing the request, incoming request and outgoing response, and auditing them. So in the real world application, when you start working for companies, they have this provision that every data that they deal with, every user data that comes into their system and goes out of their system, everything has to be logged somewhere. It's called auditing. Okay, every company every year gets an auditing check, where auditors come and check if they're like, they basically check if any company is capturing only the information it needs to capture, or more than that. Like, you cannot print a username's password. You cannot print like, if you're developing a banking application, you cannot put a log like this where you basically print the entire user object where you have the password there. If you do that, the auditors will eventually find out, and then your company will be in big trouble. Okay, so in those cases, what happens is, let's say your request comes and you need an object which will capture that request, audit it. When I say audit, it basically means saving it in the database. And when the request is when the request is being sent out as a response, that response is also going to be captured and saved in the database. This, for this thing, you can create something which will only come to life when a request comes, and which will be garbage collected when the request goes out of system. In cases like that, you would be using something called, you would be using a bean called with the scope of request. Does it make sense? Like, if this is your system, okay, let's say this is your client. Okay, your client wants to know what is the temperature right now, so it sends a request. Okay, and your server sends a response back to your client. Okay, what happens is, at this point you can create a bean. Let's use this icon, this. Okay. This would be of your request scope. What I have seen practically is, when the request comes, this bean is going to basically dump your data into the database, and whenever the response is about to be going out of the system, it will dump the response in the database, and then it will destroy itself. Okay, this is a very valid case of use case of this request scope that I have seen, at least in my experience. And yeah, that's basically it. Prototype I have very rarely seen being used, because the problem with prototype is that prototype, if you define a class and you mark it as prototype, and then you, let's say you have a post construct on it, the post construct will be called, but the pre-destroy may not be called. So many of the times, the prototypes, if they are not kept in check, can result in huge expansion of memory, which is why prototypes are usually not used until they're the only option of using it. Okay, in my experience, most of the time we just annotate this as service and we work with the singleton, it works just fine. Okay, cool, that's about it. Since we have some time, if you guys want me to explain something that you didn't understand in the previous class, please let me know. I'll explain it now. or we can go to the, hang on. Do you guys have the, do you guys have the assignment updated here? No, you guys don't have the assignment updated here. Let me just take you through the assignment for this particular session. Okay. So whatever we have learned for the last 3 days, okay, you can see here that up until this point, up until the assignment 4, it is basically, it has nothing to do with Spring Boot. It has to do with your dependency injection and all those things. From assignment 5, your actual Spring Boot assignment starts. Okay. In here, you have basically, you have to build a Spring Boot app. It's very similar to what we did. Just go through this. If you still have any issues, let me know. But I am expecting that you guys, you guys build this thing on your own. If you need help, get it from Stack Overflow, or do Google, because that's what we software engineers always do. We don't have answers to all the questions, so we Google on Stack Overflow and we find it. Idea is that you finish it in the cleanest way possible. It's not a very big task. Your major tasks actually start from here: assignment 6, assignment 7, and all of these things. This is where you actually get into the REST API and all those things. Okay. Cool. That's it from my side. If you guys have any questions, we can do that. Otherwise, we can finish this session. Vishwesh, you
Hello,
have,
sir.
yeah.
Yes, sir. Like regarding from past 2 or 3 classes of the starting, where it is told regarding container, what is Spring, and regarding the loose coupling and tightly coupling things.
You want me to explain that? Okay, cool.
Yes, sir. Like
Okay.
I don't know, like regarding the other folks, if they want, they can leave. I just don't want others to force to.
Cool. If you guys are okay, you guys can leave, or if you guys want to stay, you guys can stay. Okay, but I'm just gonna take you through the dependency injection thing. So let's see. We were in core fundamentals. Okay. All right. So it'll be a very quick introduction. So firstly, you have to, before I tell you about why the dependency injection concept came into being, I have to tell you, uh, what was the problem with this thing. Okay. So let's say, okay, let me just create a new class, new package here. I'll delete it afterwards. Okay. Example. Okay. Let's say you have a task. Okay. The task says, sort a given list. This is a simple task. Okay. Sort a given list. The stupidest way of doing this would be to create a sort class, have a sort method. What is it saying? Sort a given list. That means that you have to return a list given to you. Okay. You would write a list of, let's say, integer sort. Okay. Let's say somebody gives you an array, because most of these questions come with this assumption that it's an array. Okay. So you would have something like this array. All right. I'm not going to explain the sorting mechanism, but what you see here is, let's say you decide to do it in 2 steps. Okay. Your input is an array. Okay. And your output is basically a list. This is what is expected of you. Now, when your input comes here, let's say you do it in 2 steps. First, you convert the array to list. Second, you apply your, okay, let's say these are the 2 steps you use. I know there are smarter ways of doing this thing. You can do it with the list itself, but let's just say this is the process you have to follow. Okay. That you have to convert the array into a list, and then you have to apply your sorting logic. Okay. Your job is to basically sort a given list, but you have written your API in such a way that it first takes an array and then it basically converts the array into something that you can use. Then you apply your logic in there. If I do it this way, then what I will essentially do is I will say final list of integer list. Okay, arrays is the utility class. As list, here I'll just pass the array. This part, what it will do is it will internally convert this array into a list. Okay, so this is the creation phase. Okay, next part is your execution phase, also the part where you actually use this thing. Okay, this is where your sorting logic goes in. After this, you can basically return the list. Okay, if you look here, if your job is to sort a given list, you don't have to take in an array and then convert it to a list. Basically, you don't have to work with this. Do you guys hear me? Hello?
Hello, sir. Your voice is breaking. Like the screen
Voice
was
is,
paused for. No, no, the
voice is
screen
breaking.
was paused.
Okay, okay. Let me just try this again. Right, man. What's wrong? Speed is going down. That's why it's happening. Is this fine now? Can you guys see my screen?
Sir, yes, sir.
Okay. Okay. So basically what I did here was I said that if this is my functionality, sort a given list, then if somebody is giving me an integer here, okay, I am basically doing two things. I'm first creating the list and then I'm executing, like I'm working with the list, sorting it, and then returning the list. Okay, I can avoid this creation phase because that's not really my responsibility. Okay, in the software industry, we practice something called single responsibility principle, where a class is given only one particular responsibility and nothing else. So we can clearly avoid this phase. Okay, why this way? Because let's say tomorrow, let's say your method is this ascending order. Okay, tomorrow you have another method which basically says that you have to do the same thing for descending. Okay, you will do the same thing. Now let's see what's happening here. You are first creating this thing from this array list. Okay, instead of doing it like this, let's just say that you are using new array list, where you basically dump in the data. Okay, you're using array list here. Also for this one, you're using an array list. Okay, tomorrow if you find out that there is a different version, like there is something else, like let's say linked list works. Okay, let's also change this to array list. Let's say you started out like this. Okay, array list, array list. Tomorrow if you figure out that linked list is better than array list because it's more memory efficient, or it consumes it runs faster or something like that, if you change this to linked list, then you will have to change it here, you'll 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 have to change it here. Okay, what am I trying to demonstrate with this thing? If you have a serious class where you are using, where you're actually creating the data that you're going to work with, and then you're working with it, then you, at this creation phase, you have to make a decision of what type of data you're going to use. Like if I'm working with map here, if I am given the responsibility of creating the map, then I have to decide whether I want to use a hash map or linked hash map. If I'm using list, I have to decide whether I'm doing a linked list or a simple list or some other thing, right? This is basically a tight coupling. Why is it tight coupling? Because tomorrow if something changes, if you decide to not use linked list but something else, your method here, okay, whose sole job is to just sort a given list, okay, whose sole job is just to sort a given list, is directly tied to the creation phase. This sort of phenomenon is called tight coupling. Does this make sense to you, Vishwish?
Yes, sir.
This is a tight coupling because at the creation phase, you cannot avoid this thing. Even if you use a list here, even if you use just the interface here, still here you have to change, you have to make changes here, okay? The idea here is if you do not need to create something, then don't create it. Have someone inject that value into you, okay? One of the ways to do that is basically by I'm just saying that I won't be creating this part, so I will get rid of the creation phase here. Instead, what I'll do is I will have it injected array list integer list. Okay, so what I did here is, if you look at these two methods, you can see the difference is very clear. This guy is actually creating the data it wants to work with. This guy is just consuming the data it wants to work with. It does not care about the creation or how it is getting created. It just says that I need this data to work with. So I'll just take that. My method, whoever is calling me, will have to give me the data already created. I'm not going to create it. However, this guy is saying that I'm going to work with the list, but you're giving me some different form of data, so I'll have to take care of creating this data. So this guy is actually creating the data it needs. This creating part is actually what causes trouble, because in the future, if the implementation changes, then this is just one line of code, but imagine writing a real method where you have 50 such instances. You have to go and make 50 such instances changes. Okay, that is not at all a good practice. Okay, this is why what we did here was we said it that, okay, inject the list that I'm going to work with. Now, this did loosen up the coupling. Okay, this was previously this is tightly coupled. This is now loosened up, but partially. Okay, if you look here, we are still tightly coupled to just a particular implementation, that is array list. Tomorrow, if you have to use linked list, if you change linked list here, you would have to change linked list here, and then wherever else you have used a linked list array list specific function, you'll have to change all of them to a linked list. Okay, this is the disadvantage of using implementation instead of interface. Okay, let me repeat that again. If you are using array list here, let's say the array list has a very specific function, okay, custom func, something like this. Okay, this is only specific to array list. Okay, tomorrow when you have a linked list, if you change this to linked list, you would also have to change the return type to linked list. Then this function won't be available to you anymore, because that was only available to this thing. Do you see the problem with using implementation and not interface?
Yes.
So if instead of doing any of these things, if we had just used the interface, okay, in both the cases, then none of this would be a problem. Your method is not creating anything, which means it is not tightly coupled. Your method signature is not tightly coupled with a particular implementation, so it is just using the interface. This phenomenon of using just the interface types to do your programming, this phenomenon is called programming to interface. This is a software engineering best practice, and basically this sort of thing where in the method you basically write your method in such a way that you only get the data that you want to work with, but you never create the data, because that is not your responsibility. This sort of injection. So somebody is creating the data and injecting it into your method. This is called the dependency injection. Why is it called a dependency injection? Because your method is dependent on a list, and that list is being created by someone else and he is injecting it into you. This is basically dependency injection, and this is called uh, loose coupling. This is how you actually loosen up the entire tight couple. Make sense? How does it happen? I'll show you right now. If I write a main method here, if I want to use the sort description, let's say I create an instance of sort. Okay, new sort. Okay. If I want to use this sort descending function, I would have to give an integer array. Okay, so I would have to probably give I don't know, new integer, something like this, 3, something like this. Okay, I would have to give an integer. Let's say you change this thing to basically an array list. Okay, you're not dealing with this creation phase anymore. You are partially loosely coupled, but not completely. Why? Because now this guy will take only an array list. Okay. If tomorrow you have a linked list, let's say you say final list integer list. Okay, let's call it list1 new array list. Okay, you can see that you will not be able to inject this list1 here because the expected value is of type array list and you are injecting a list, so you will be forced to convert it to array list. Okay, however, for your second method, which is array ascending, okay, you can create a list integer. I'll name it list2 new, let's say array list. Okay, and I'll say sort dot sort ascending. Okay, here I can just pass the list2. All right, done. Now if tomorrow you decide to change your array list to something else, okay, because main is the guy who's responsible for creating the data, it can simply switch to linked list. Okay, it can simply switch to linked list and everything would work fine. So what did we do here? We programmed to interface and we injected this value into this guy. Okay, you cannot do the same thing here because you are now tightly coupled to a particular signature and basically a particular implementation of this. That's it. This is the basic difference between programming to interface. I mean, this is the basic difference between tight coupling and loose coupling. And this is how you implement programming to interface, which is why in our Spring application, even if it's just a simple function, I'm always creating an interface first and then implementing it. Make sense? Vishwish?
Yes, sir.
Cool. Any more questions, guys? If there's no more questions, we can end the session. Thank you for joining. Have a good night.